787.
Char 787 presents The Locker Problem. An amazing math question for you to solve. You start off with a school. There are 10,000 students waiting to enter the school. Inside the school, there are 10,000 lockers, one for each of the students. I only drew 18, so there are 9,982 more lockers from what I drew. All the lockers start off as the closed position. There are 10,000 students waiting to enter their classrooms, but to enter the classroom, they must pass the hall full of lockers. The first student comes and decides to open every locker. So now every single locker is open. The second student comes and decides to close every second locker. So the second, fourth, sixth, 8th, 10th lockers and so on are now closed, all the way up to 10,000. The third student comes and decides to reverse the state of every third locker. So now the state of the 3rd, 6th, 9th, 12th, 15th, so on lockers are now reversed. For example, if the locker was originally open, it's now closed. If it's closed, it's now open. The fourth student comes and decides to reverse the state of every fourth locker. So now the state of the lockers 4, 8, 12, 16, and so on lockers are now reversed. Continuing this pattern until the last person, the 10,000th person, changes the state of the 10,000th locker. Once all the students have passed, how many lockers will remain open? Also, try to find all the lockers under 100 that aren't closed. You think you can figure it out? Here are a few things to consider. There are 10,000 students. There are also 10,000 lockers. Every student reverses the state of their locker number. For example, student 3 reverses the state of every third locker, starting on and including 3. All the lockers start as the closed position. Pause the video now if you want to figure it out. Answer in 3, 2, 1. Continue this pattern up to 20 in a chart. I recommend doing is making a graph paper and drawing out the locker numbers and the student numbers on the left. Do the pattern. So for the first student opens all the lockers, second student closes every other locker, third student reverses the state of every third locker, and so on. In this diagram, C is for closed and O is for open. So if you continue this pattern, you will start seeing a pattern in the lockers that are open. So the lockers that remain open so far in 20, when you go up to 20, is 1, 4, 9, and 16. Now you know that these are the final results for the lockers that will remain open for this chart, is because you worked your students your way all the way down to 20. So for the next student, which is the 21st student, the first and smallest locker number it will make a change to is 21, and that's off this chart. So you know that these are the final results for the lockers up to 20. So if these are the final results for 20, take a look at the numbers 1, 4, 9, and 16. What is common about these numbers, or what type of numbers are they? If you said that they are all perfect squares, you're right. This means that only the lockers that are perfect squares will remain open. If you're not satisfied with this conclusion, go ahead and remake this diagram yourself, only this time make it beyond 20. All the lockers that remain open are always the perfect squares. So here are the final answers. Find all the lockers under 100 that remain open. Answer: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. How many lockers will remain open at the end? There are 100 perfect squares under 10,000. Therefore, there will be 100 lockers that will remain open. Which lockers will remain open? Answer. The lockers that will remain open are the lockers that have their number as a perfect square. The locker problem. If you want more math or riddle videos like this one, leave a like and comment what I should do for my next one. Hope you enjoyed. Char 787. Char 787.